Lesson 8.5, using distributive property. So this is slightly misleading because distributive property is something that's taught in pre-algebra very early on. I feel like this would actually be better called reverse distributive property so that you understand what we're talking about. But honestly, it's the distributive property or else you couldn't do it. So our objective today is to use distributive property to factor and also to solve equations that are in the form of ax squared plus bx equals 0. That just means that you would have numbers for a and b, but you want something that would have a squared term and then just a regular x term. So we will be solving equations too. So again, really reverse distributive property. It's otherwise known as factoring. Factoring leaves the answer in the product form. What's product usually mean? Ariana? Multiplication. So what's going on here is you're leaving it look like a multiplication problem. You're leaving it look like a multiplication problem. So here's the deal. These are the steps we're going to follow. You're going to find the GCF, greatest common factor for all terms. You're going to write whatever that GCF is in front of a set of parentheses. Then you're going to divide out or factor out the GCF from each term and write what's left in parentheses. Okay, all that together probably sounds a lot more complicated than it really is. I think this first part you'll be fine with. Let me scroll down here just a little bit so we get to see some more examples. All right, so example A, 15x plus 25x squared. As far as the numbers go, I'm hoping that GCF should come pretty naturally to you since you're in algebra. Taking out the greatest common factor of 15 and 25, I'm hoping most of you could think of that pretty quickly. What would be the greatest number that could go into 15 and 25, Olivia? 5. So as far as our GCF here, you're going to start off with a 5. Now let me tell you a trick about the variables, okay? The greatest common factor of the variables is the least amount of them. The least amount. GCF, greatest common factor, is the least amount of the variable. So if I look at my two terms, there's one x there and there's two x's there. What is the least amount, Octavia?
1.
So 5x is my GCF of that term, of the polynomial. Okay, so I write 5x in front of parentheses. Here's what you do now. Reverse distributive. If I divide out 5x from 15x, what would remain?
3x.
Not an x, just a 3. We're taking the x out. Just a 3. All right, if I take 5x out of 25x squared, what would remain, Ben?
5.
Not just 5. 5x. Now, let's discuss that. This 15x only had an x. When I take an x out of it, it's gone. But 25x squared, if I take an x out of it, there's 1 left. Do you see the difference? Now, here's what you can always do. If you're a little leery here at the beginning of this stuff, take your answer and distribute it back. If you come back to where you started, you got the right answer. Does that make sense? If I took 5x times 3, I'd get 15x. And if I took 5x times 5x, I'd get 25x squared. Now, don't mess up and circle this as your answer because that's definitely not. That's the problem. You right? This back here would be your answer. 5x times the quantity 3 plus 5x. We're factoring out greatest common factors. Okay, example B, 3x squared y plus 12xy squared. So, you start off with the numbers. What's the greatest common factor of 3 and 12, Avery?
3.
So I'm going to take a 3 for sure. Then you look at the x's. Well, the first term has 2 of them. The second one has 1 of them. How many am I going to take out, Jared? 1. Then you look at the y's. The first one has 1 y and the second one has 2. So how many am I going to take out? 1. You take out the least amount of the variable. So my greatest common factor is 3xy. Write that down. Start your parentheses. However many terms that I have here, that's how many terms I'm going to end up with here. You have to have 1 for 1. Even if you factor out the whole thing, you would still have the number 1 remaining. If I take 3xy and divide it out of 3x squared y, what do you think is left, Avery? X. And if I take 3xy and divide it out of 12xy squared, Olivia, what's left? 4y. Does anybody have questions about that? If you're confused or you're unsure of your answer, distribute it back through. Make sure you end up where you started. Okay, next, let's do a trinomial here. AB squared plus 15a squared b squared plus 27ab cubed. All right, my numbers, 1, 15, and 27. Oh my goodness, what can I take out of that? Jared? Yeah, so I'm not going to write a number. A, I have 1, 2, and 1. So what's my least amount? 1, so I'm taking out an A. My B's, I've got 2, 2, and 3. How many am I taking out? 2. Now, my greatest common factor of each one of those terms is AB squared. I start with the first term. If I have an AB squared and I divide out an AB squared, what in the world's left? 1. It's got to be at least a 1, because if I distributed that back through, wouldn't that be how I would get the AB squared back? I'd have to have a 1 there, correct? All right, the second term. If I take AB squared out of 15a squared b, what would be left? Well, for sure a 15. Would there be any a's left?
Yeah.
Yes, an a. Would there be any b's left? No, so a 15a. And then finally the last term. If there'd definitely be a 27, would there be any a's left?
No.
Would there be any b's left?
Yes.
1, good. So AB squared times the quantity 1 plus 15a plus 27b. Josh, question.
What happens if the variables fall out?
If the variables fall out, then you have to at least leave a 1 there. Is that what you're talking about?
Like, I'm just like looking on the homework, and like it says like so the first one it says 64 minus 40 AB, and like wouldn't you have to put like the AB for the
I need to see that problem that you're talking about. The first one. Oh, on 64. Okay, he's saying there's a number and then there's something with a variable. So let's say if it would be 5 plus 10AB. Okay, so out of my numbers, I would definitely factor out a 5, but there's no A and there's one A. What's the least amount?
0.
None. So you're not going to take an A. And B, there's no B and one B. What's the least amount?
1.
No B. So you're only taking out a 5. So you'd have 1 plus 2AB. Okay, so you may not have any variables that you take out. Okay? All right, good question. Yes?
Wait, can there be fractions?
There could be fractions.
Couldn't you have done like for the C, put a 3 and then make the first?
Oh, no, no, no. Don't take out to make them have fractions. No. No. Don't make them have fractions. Because that first one has a coefficient of 1, so that means you're not going to take any number out. Yeah.
And for the first one, wouldn't you like put it in, like in the parentheses, would you do 5x plus 3 for the next?
You could go back and put that in standard form and put 5x plus 3, but you don't really have to if we're just factoring. Maybe if we're solving and simplifying things out a little bit better, you could. If you did, it definitely would not be wrong. Probably actually more right. So Anybody else? All right, let's talk about solving equations now. So basically what we have here, the first 3 examples, there's no equal sign, so you're not solving for an amount. But once they start throwing equal signs in there, that's when you have to start solving for problems. Okay, so let's check this out. What's going to happen here is you're going to factor, and then you're going to have a product like A times B equaling 0. Well, in order for something to equal 0, one of them has to be 0, doesn't it? You can't multiply and get 0 unless you're multiplying with the 0. So either A is 0 or B is 0, but you don't really know which one, so you got to say, well, maybe they both are, and that's exactly what you do. So if you would have a problem like this, 2x times the quantity x minus 3 is 0, you have to set up these 2 problems. You have to say, well, maybe 2x equals 0, or maybe x minus 3 equals 0. You solve them both for x. So you're going to have more than one solution. Okay, more than one solution. So the first one there, divide by 2, so x could be 0. Or the second one, add 3, so x could be 3. So your solution set, you know, remember set notation, those little squigglies, right? 0 and 3. You got to list them both. You got to list them both. So on your assignment, they may have you factoring out some things like that and solving. Okay, set them both. Or they might already have it set like this example D. So just for the sake of practice, let's say it's already factored. X minus 3 times 3x plus 6 is 0. So you would set both of these things equal to 0. And you solve them both. So I would add 3. So one of my answers is 3, and the other one, I subtract 6 and divide by 3. My other answer is -2. So remember, you factor it out so you get a product. It's got to be equal to 0, which these will be today. You set each part equal to 0 and solve it. So some of them you will have to factor like the ones above. Some of them will already be factored for you. Questions about factoring? Yes?
Is there any specific order where I might have to write the set?
There really isn't. Some people might be really picky and say least to greatest, but honestly, as long as you got them both in there, you're good. Yes?
It's like solving absolute value.
It is like solving absolute value. Yes, you're going to have more than one answer, sort of like that. Ben?
So when you're doing it, you don't have to have it that comes up to 0.
What?
So when you're like solving, you don't have to have it.
No, one of them does not have to be 0. It may be 0, but does not have to be 0.
We had 3 and -2.
What? Right. 3 and -2, so one of those wasn't 0. Yep. Tora?
I was going to ask what if it wasn't equal to 0, and like on our homework we have 28, and it's...
Write this problem down. Let me think a minute.
18x squared equals 15x.
Yeah, there's no plus.
Okay.
And then 129.
Okay, hold on. Let's do this one. 4x. So you set them equal to 0. You add the 5x, set it equal to 0, and then factor. Okay? So that's what you would do on those. If they're not equal to 0, you bring everything over to the other side so it is equal to 0.